Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Harjas. For math homework help, call in Bakersfield 636-4357. Everywhere else 1-866-636-6284. The email is dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Harjas, where do you go to school and what grade are you in?
Berkshire Elementary School, and I'm in 6th grade.
How was 6th grade?
Amazing.
Amazing. What's so amazing about 6th grade?
Like, the teachers are really nice, the staff's really good.
Good. So do you know where you're going to go to school next year?
Most likely Stone Creek Junior High.
Okay, and is there anything that you're really looking forward to when you go to school next year at junior high?
The programs like PLTW and AVID.
Okay, so you're looking forward to that stuff. Good. So PLT, Project Lead the Way, is that what that is? Good. All right. And what about those programs made you interested in them?
Because in the 8th grade year for PLTW, there's robotics, and I'm really interested in robotics.
Oh, good. All right. So do you do any of that now, or are you excited just to learn about it when you get there?
A little bit in STEM.
Okay, good. So you do that at your school now, right? Or
No, like
someplace else?
because during a few school years during COVID, on Zoom there's STEM classes where there's robotics.
Oh, all right. So that's what got you into the whole thing. All right, good. Well, you're going to do a little bit of math today. We're not going to do any robotic work today, but you're going to be cool with that?
Yep.
All right. Well, first, let's take a look at today's problem of the day. You're going to help me out with this one, all right? All right, let's take a look at it together. So this goes out on different social media platforms, and it says, what is the value of t? Right? Makes the equation true. So we have 4,009 times 3 is equal to 4,000 times something, and we need to know what t is, plus 9 times 3. So when you look at that, what are you thinking of right now? What's the first thing you think we should do as far as solving for what that t is?
4,009 times 3 to get what we're looking for.
Okay, so what do you want to do? I mean, do you have an idea on which one of those might be the correct answer?
Maybe 3?
So you're thinking D3? Why that one?
Because the other ones seem like a little high for this equation, while there's like already a lot of multiplying.
Okay, so 4,009, what they're doing is, you see on the other side of the equal sign, they're breaking it up into 4,000 and 9. Okay, so that takes care of the 4,009. So what is 4,009 being multiplied by?
3.
Okay, so we see the 9 is being multiplied by 3. What else has to be multiplied by 3?
4,000.
The 4,000, right? Because it's not going to be 4,000 times some other number, right? Because it's 4,009, all right? So, and it makes sense, right? Because 4,009 times anything other than 1 is not going to be 4,009, is it? Okay? 4,000 is less than what it is, all right? 9, why do you think 9's up there?
Because then the problem would be too easy because t would be 1.
Okay. Do you see how at the beginning they put 4,009? And do you think some kid might look at the first set of parentheses and go 4,000 and it needs a 9 at the end? Somebody might look at that and think that way, right? And that's why they put 9 in that answer right there. But you're definitely going with D3, right? All right, let's take a look and see if indeed you are correct. All right, there you go. First problem done, huh, dude? That wasn't that bad, was it?
Nope.
All right. 636-4357 is our phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Programming note, next week is the final week of live broadcasting for Do the Math for our 22nd full season. Time flies, doesn't it?
Time flies.
Because We were both here during season
Yes,
one,
we
and
were.
it goes by pretty quickly right there. Anyway, time now for today's Math in the News. All right, today's Math in the News. Well, you know what? This is a very special treat because joining us today, we have Andrew Schwartz. And Andrew, how are you today? All right, so I saw your mouth moving, but I wasn't able to hear you, and hopefully the kids at home can hear you right there. But you're with the Central Sierra Snow Lab, correct?
That's correct, yes. I'm doing very well up here, and it's snowing a little bit, actually, currently. We do all kinds of different things. I've been here for about 3 years at this point, but we do a lot of measurement of our snow, of our atmosphere, to look at all things weather and water and climate.
Okay, so where exactly are you? Because we know you're up north from where we are, and you're in the map, but where are you?
So we're just northwest of Lake Tahoe by about 45 minutes. So if you've ever driven I-80 over Donner Summit, Donner Pass, that's roughly where we are.
Okay, well, we've got some slides here. We're going to talk about snowpack and the water amount in it and things like that. So you ready to go?
Absolutely, let's do it.
All right, let's take a look at the first one. So water and snow in the world, and we know that mountains is where all the snow is, right? And that snow pack in the mountains is what provides the water for most of the population.
That's exactly right. There's so much of the world that depend on snowpack for their daily water. In fact, here in California, we depend on it for about 30 to 50% of our water. But around the world, that can vary greatly. Some people depend on only snow and its meltwater for their water resource. So it's incredibly important all around the globe.
Okay, so let's go to the next slide. And we can see, and a lot of kids are probably going to look at this and recognize that that is part of California right there. And we can see the Southern Valley and the mountains around it. So talk to us a little bit about the mountains that we're looking at.
Absolutely. So when we look at the mountains that we realistically get our water from throughout the southwestern United States, you know, the big one that we talk about so much, especially because the labs here in California are the Sierra Nevada. They kind of take that moist air coming off the Pacific Ocean and scrape the moisture out of it. But we also have mountains like the White Mountains, the Rockies and the Wasatch, further to the east, and all these feed water into rivers like the Sacramento, like the Feather, like the Yuba, and the Colorado, of course, and all of those feed into our water resources that we use for things like our daily showers, our food that needs to be grown by agriculture, and just our overall uses in general.
Okay, so quickly, I know that you're with the Sierra Nevada, that's where you work. Are you able to, or do you travel to some of the other ranges?
Yeah, I actually grew up in Colorado, so I spent a lot of time in the Rockies, and I kind of travel all over depending on where the work takes me. Sometimes we go up into the Cascades, sometimes we go into the Rockies, or occasionally we'll even go out to Australia because they have snow and kangaroos there as well.
All right, so here we go, and now we've got a video. So just kind of talk us through the video, what we're looking at.
So this is one of our daily measurements. We do measurements twice a day at 8 a.m. and 4 p.m. And you can see in this video, it's very windy. This is actually a storm that came through last week and dropped 6.5 feet of snow. And so we're going out there continually taking measurements and then going inside, of course, doing the math to figure out how all this new snow translates into water. And it's kind of fun. You know, it's a bit like being an adventurer going outside in these crazy conditions in order to make these measurements for science.
So did you grow up in an environment like this? Because growing up in New York, I mean, during wintertime, it was always fun to go out in the snow and fun and play in it. Never thought about having to work in it. Did you grow up in an environment like that where you're like, oh yeah, it's cool, we're gonna go out and play in the snow, now I get paid to do it?
Absolutely. Yeah, I grew up in Denver. You know, we didn't get as much snow as we get up here by any means. We get about 30 feet of snow on average up here, and we only used to get about 5 to 6 feet on average down in Denver. But I always used to pretend that I was in Antarctica or these wildly snowy and windy places doing science and doing research and kind of being an explorer. And so now there are those moments when these storms are coming through and I kind of sit back and realize that I might have grown up, but I'm still just a kid playing in the snow a little bit.
Well, there you go. That's the fun. And as you said, doing science. And I think the biggest thing about that and the most fun is that you're actually hands-on doing something. You're not in an office or in a cubicle. You're out doing things, and as you said, able to travel to different places and actually do stuff and have it as a career.
Absolutely. You know, that's one of the best parts is as I'm doing this work, we get to go out and kind of ski around on occasion. So even skiing can be part of work. But yeah, we get to go out and dig snow pits and measure snow a lot of different ways. And it really does feel like being a kid at times because we're out and we're doing things in the field and not just sitting in front of a computer screen for 8 hours a day.
All right. Well, I know there are times when you can't exactly go out easily. Talking about some of the latest storms, when people open a door and all they see is a wall of snow, that's a lot of snow right there. So talk a little bit about the snowpack, how much that would be, and then the water content in that.
Yeah, so when we look at the snowpack, you know, just from this recent storm, we got about 6.5 feet out of that storm. When we open up our door, of course, we have to shovel a lot of that out of the way. But when we compare the water that comes out of that, it's not necessarily 6.5 feet of water because when snow falls, it has different densities, right? As it falls out of the sky, it's about 0.1. And so we get about 10 inches of snow for every inch of water. After it sits in the snowpack and kind of compacts, it's about 0.4 to 0.5. So we'll get 4 or 5 inches of water to every, we'll get, 4 or 5 inches of water out of 10 inches of snow. So it kind of changes things. So when we look at a snowpack that's 6.5 feet deep after the most recent storm, we're only going to get about 2.6 feet of water out of that. So it's not the whole amount, but it is still plenty of water that comes out of that snow.
All right, and we can see on there that you've got the density at 0.4, and we were talking a little bit about density where students that may not have experienced snow yet, but they have seen, or maybe they've had some experience with it, and a lot of times they'll pick up a handful of snow and you can kind of blow it away a little bit. But we want it more dense so that you can, I mean, and we were talking about it, but a kid can make a snowball with it a little bit better, where it's going to fly better because of the density of the snowpack.
That's exactly it. Yeah, the snow has, of course, different densities. And when it's dry, it doesn't have a whole lot of water in it. So we tend to like dense snow for a couple different reasons. For one, it has extra water in it when it is dense. And for two, it makes those better snowballs, those ones that compact really easily, that fly a lot farther and are just better to throw in general.
All right, so now the next slide we're looking at are some of the instruments that you use to measure the precipitation.
Yeah, so these are precipitation gauges, and if you can imagine kind of a bucket sitting in the middle of them, snow and rain will fall into them and fall into that bucket, and then we'll get a reading like what you see on the right there. There's a lot of moisture that builds up, and you can see it track up during specific storm periods. And so that'll measure the amount of liquid water that is accumulating, even if it snows. So that moisture, or that liquid that's in the bucket in there, will actually melt the snow so that we can get the total amount of liquid water out of it.
Okay, you were mentioning earlier about measuring precipitation in snowpack, and you said it was done at 8 and 4. Is that no matter what is going on, all of the time it's always 8 and 4?
So when we go outside and do the actual measurements ourselves, that's done at 8 and 4. Our precipitation measurements with those gauges that you just saw, those are done every minute throughout the day, and they just report back to us in the lab. So we can just pull that up on our computer screen and see how it's going. But our measurements when it is snowing are always at 8 and 4, and those are always done by a person.
All right, well, the next slide looks as though you're in a bit of snow. So you're in these pits. So how high up on the chain are you where you're digging these pits, or are you assigning people to dig the pits?
Well, typically I'm assigning people to dig pits, but to be honest, digging in the snow is still one of my favorite things to do. So you can see me in the middle there. I still love to dig down and hop in them. When we're in these pits, they can range anywhere from just a couple feet deep to, you know, last year where you can see those people on the right, that was about 16 feet deep. And we're taking measurements of the density of the snowpack, kind of like what we were just talking about, but we're also taking measurements of the temperature, because when we combine the temperature and the density, that can tell us how quickly that snow is going to melt when we look at things like the sun and its contributions versus air temperature and things like that. So we have equations that'll help us take that snow density and temperature and tell us how much melt we're going to get out of it based off the weather we're experiencing.
Right, and I'm glad you mentioned the part about the air temperature, because obviously the deeper down you go, because snow is a natural insulator, and it's going to be a little bit warmer, but down at the bottom, the snow itself won't be.
And that's exactly it. Yeah. So snow is a terrific insulator. The warmer temperatures that we find in our snowpack, believe it or not, are actually at the very bottom. The cold temperatures are at the top because as the snow falls, it traps air from the storm in with it. And that means that the coldest temperatures tend to be right at the top. And then as they get further and further down, they warm up as they're closer to the ground because of that insulating factor.
All right, so next we're going to look at some of the instruments that you're using that students at home could actually do as well.
That's exactly it. Yeah. So I included this slide because this is one of the most important measurements that we do here at the lab, and it's something that kids can easily do at home. All you need is a good ruler and a clear plastic tube or even a glass from your kitchen would work, and then a kitchen scale. And so what we do is we go out, like you mentioned, at 8 a.m. and 4 p.m. and we'll measure the new snow. So the way this works is we put a board out, and you can see that board in the center picture underneath the tube, and we let the snow accumulate on that board. And then we'll go out and measure how deep it is after a certain period of time. And we'll also slide our plastic tube or glass over it, and then we'll weigh it. Of course, we want to make sure that we're only weighing the snow. So we'll what's called tare, or we'll kind of make sure that the glass is tared out and that we're only measuring the snow when we put it on the scale. But that'll help get us the density of that new snow and the water content that's in it as well. This is, like I said, the most important measurement that we do at the site, and it's something that anyone can easily do at home as well.
Right, and kids would be able to do this at home, as you just said. Now, we're just going to touch for a couple of seconds on tearing, because as you mentioned, and there are probably high school students who are going, yeah, we know what you're talking about, but there might be some younger students that haven't done labs with these yet. But you're basically putting the tube on first and then tearing it so that it zeroes out, so that the only thing that is actually being measured and weighed is the product inside of it.
That's exactly it. You can actually weigh the tube separately and then weigh the tube and the snow together and then subtract them. But that generally, we're all about efficiency, right? We want to do things as easily as possible. So putting it on the scale and tearing that out and weighing that by itself and then removing that weight so that we're only measuring the snow after the snow's inside of it really makes our job a lot easier.
All right, good. So we're down to our last slide. And talk to us about the federal sampler.
So the federal sampler is really, really easy. It's just a hollow aluminum tube that we shove into the snowpack. You can see on the left there, that's one of my employees, and she's shoving that tube that'll go all the way down through the snowpack. So when we put those in, sometimes it'll be as shallow as a few feet, sometimes they'll go down even 24 feet. And the way this works is when you shove it down, it'll hit the ground, hopefully, and then as you pull it out, it'll collect a sample of that snow. And you can see in that middle picture, there's a sample of the snow in the end of that tube, and we've got it on a scale. And when we weigh it, it'll tell us the weight and how much water is in that snow. And then we use that to determine what the water is going to look like for our reservoirs and how our water managers can accurately adjust their outflow, their releases and outflows to deal with that incoming water.
All right, so I know that you were talking about hopefully you hit the ground, because that may not happen all of the time. As you were talking about, you may hit a layer of ice and think you hit the ground, but you're actually not there yet. So you have to move a little bit. Are there times when you have driven that sampler and you know you're not at ground yet?
Yes, it can be really hard. So one of the things about snowpacks is they're layered kind of like a cake, right? And we have different layers with different densities and different structure, and sometimes we'll hit ice layers that are so hard that you can't actually get through them. And as you said, we'd have to pick up our sampler, move it to a different location, because it could be a solid layer of ice that might be an inch or two thick, and no matter how hard you press on that tube, even though it has cutting teeth on it, it'll actually just sit there and spin on top of it. And so it can provide quite a challenge sometime to get all the way to that soil surface.
All right, so Andrew, I know that you were talking about how you grew up in Denver, you grew up around snow, and you're always in it and things like that, and it kind of led you to where you're at today with the career that you have. What are some things that students can do they're looking at this going, hey, you know what, this is pretty cool, I don't live near snow, so I don't have an experience with this, to get them into this field?
Well, realistically speaking, my background wasn't in snow at first. I started off in meteorology, which is the study of weather, and whether that's just looking at what type of clouds are in the sky that day or making a note of how windy it is, it's those observations that we're so focused on here at the lab and in our careers. And that means that anybody can do it too, just taking note of those weather conditions, keeping an eye on maybe the news that's coming out about the water supply and the weather that's going on and the shifts in climate that we see. And so realistically, again, even if you're not living around snow, it's really easy to become engaged in things that are kind of in the neighborhood of it, because a lot of our water, in fact, all of our water here on land, for the most part, comes from either the sky or our aquifers under the ground. And so much of understanding our snow and our water starts and ends with the weather.
All right, well, Andrew, we certainly do appreciate you taking some time to visit us here on Do the Math. Some outstanding work, a great career, and just talking to the students about how important it is because of the importance of water and snowpack to where we live in the Western United States. So thank you once again for sharing your time with us.
It was absolutely my pleasure. Thank you for having me on.
All right, that was today's Math in the News, and we're going to check out some culinary calculations.
Hi everyone, welcome back to Radio Sandwich. Today we're working with our leftovers. Now, yesterday I made a brisket. Brisket leaves me with a lot of shredded, lovely little bits of beefy goodness. And what we're gonna do with that is we're gonna make a corned beef hash. Now, hash is just a fancy word for a meat and a potato mixed with an egg, or anything else that you might want. I found an old pepper in the fridge, and you guys are gonna see we're gonna clean off all these dirty spots, and then you can still use it. I've got some chives from our garden, right? Because we're trying to use whatever we have here. And then we just had a little bit of local parsley from H&A Farms. And none the least, we've got some local eggs from Happy Hen Egg Company. Some of you guys might know that name. And of course, we have a boiled potato left over from yesterday's soup. So, let's get started. First thing we're gonna do, we're gonna take a nice big skillet and we're gonna get some oil right there in the middle. Now, while that's heating, I am going to start in with an onion. I'm going to show you how to brunoise an onion. You're going to start by cutting off the plant side. You can see there was once a stem that grew up here, and you can see these are the roots. We're going to keep the roots on there. We're going to cut off the stem. We're going to cut down the middle right through that root. So we have two halves of our onion. This makes it, number one, a lot easier to peel. You can see, just reach your finger in between the layers. Just pull off that whole peel almost all in one. And then you'll see the roots are holding the rest of the layers on. Do it again. Now, a brunoise is a fancy French word for dice, but it's a fine dice, and with an onion, we know that can be hard. The way you can make this easier on yourself is by starting in with some slices. We're gonna go vertical first, but we are not cutting all the way through. And we're just gonna create nice, even slices all the way through. You see now we have kind of like a fan. We're gonna do the same thing, but we're gonna go this way. So, palm down, fingers always curled up when you're using a knife like this. Never down, because no, up. And then we are gonna go through the top of the onion. And again, not all the way through. Back down. And then we're gonna cut it one more time the same way. Right? Now, here's the magic. When I tiger claw, hold my onion in place. When I cut through, Look at all the dices that just fall off of that onion. So now that we've got our onion nice and diced, we're gonna put this in our pan with hot oil. Sizzle incoming. We're gonna hit it with some salt and pepper. This is our leftovers episode, so we have one pepper. It's not the prettiest pepper. It's got some spots. We're gonna clean it, and I'm gonna show you how. First thing you're gonna do is you're gonna cut off the stem side. It's got a hat now. And also on that hat, we got rid of a lot of those little nasty bits. Next thing we're gonna do, I'm gonna cut off the bottom. Now it's like a pepper sleeve with seeds inside, right? I can see you. Easiest part and most fun part, we're gonna make sure we clean off all our little spots, right? You're always gonna cut towards your buddy, not your body. There's that. Any other spots? Nope, nice and clean. Okay, we're gonna take our knife, we're gonna make one slice down the side of this pepper. I'm gonna lay the pepper flat. Knife goes back in that cut, palm down again, and you're just gonna rotate this pepper around the knife. And now I've got a nice clean sheet of pepper I can cut into strips or dice or do whatever I like. So I'm gonna do just that. I'm gonna cut it in half so it's easier to work with. Now, why do we do a claw in the kitchen when we cut with our knives? We do a claw because if we were to hold our food like this when we cut, it's a lot riskier. What we do instead is we curl our fingers like a tiger, put our thumb in the back to push the food forward, and that way when we cut, even if we go too close, oh no, I'm still not hurting myself, not even a little bit. I use my knuckles as a guide, and I stay nice and safe. Okay, peppers in with the onions. Turn our heat up a little bit, and we are gonna saute. Saute, of course, meaning to lightly fry in a little bit of oil, as opposed to, again, frying, which is gonna be a thicker layer of oil in which covers the food. Sometimes you'll see smoked paprika labeled as hot paprika. It's not spicy, it just means that it has more of a smoky flavor to it. Smell that, that's yummy.
That's funny, Miriam just did that. Do you remember, I don't know if you're old enough, I'm sure you are. Not to say you're old, but you're older than Harjas, all right? John's over there cracking up because we're the same age. Do you remember the original Willy Wonka movie and they were like smell-o-vision?
Yes.
Which is what she was, oh yeah, smell that, right? Holding it up to the camera. And
yeah,
oh, good.
Yeah.
Well, good. I'm glad you're on
I
top
am
of that
about
one. Not
old.
being like,
Yeah.
hey, old man, I don't know what you're talking about right there.
I got you.
We got it. All right, you ready?
Yep.
All right, Harjas, over to the board, young man. We've got a beautiful problem for the two of you right now.
Okay.
So you can write down anything that you want to. Here we go. 30% of a number is 8.4. So 30% of a number is 8.4. What is 37.5% of the number?
$37.5.
5%. So
Okay.
37.5% of the number, and you're going to round it to the nearest tenth.
Okay. What are you thinking?
So first we're going to solve this. 30% of a number is 8.4.
So are you going to try and get the number? Is that what you're thinking? Let's figure out what
Yes.
the number is. Okay, so if we do that, how do we do that?
We can multiply using the 30% and the 8.4.
Okay, so we're going to multiply the 30% to the 8.4? Okay, are you really sure?
Or we can divide it down to tenths.
Okay, are you really sure?
Yes.
That's what you want to do? Okay, let's give it a try and let's see what happens.
So if we divide The number is 8.4. If
Okay.
we divide 8.4 and 30,
Okay.
move the decimal out. It goes into 30 goes into 88 0 times. 8 goes into 84 2 times. Minus 60 equals 24.
Okay, so what is it that you're doing right now? Why division? Why are we moving decimals? Why?
It's like decrease the number to get it to 10%, so then you can multiply it by 10 to then give it 100%.
Oh,
then you'll solve for
I
the
see.
number.
Oh, okay. So you're trying to decide. Oh, okay. So my question to you is this. So if we're trying, are we going to get 30? Is doing this process going to get us 30% of the 8.4, or is it going to get us 30% of the number, knowing that 30% of the number is 8.4?
Doing this process, you're gonna get the number.
Okay. Okay. I'm gonna follow along. I'm just gonna watch you for a little bit.
2.4. It's 2.4, and then we already have a decimal. I'm a little confused here.
Okay, so I'm going to go ahead and stop you since you say you're confused. All right, so let's go ahead and think about number one. We're going to think about a couple of things. Okay, number one. You said 30% and we just turned it into a 30, and then you decided to move this decimal, right? Okay, so let's first think about number one. Okay, 30%. If we were going to use that as a number, it's not just a 30, right? How do we change 30% into a number? That gives us what?
A fraction?
So think about it this way. If I say 50%, what is this as a decimal?
0.5?
Right, because you did what?
Turned it into a decimal?
You turned it into decimal, right? Okay, let's go ahead and talk about this. 30% written as a decimal is? Okay, so when we are talking about doing what you're doing here, instead of dividing by the 30, what would we have wanted to divide by?
0.3.
Okay, so then that's where, so if we're going to say we're going to divide it, why are we dividing? Do you know why we're dividing?
So we can reduce the number.
Okay, so I'm going to go ahead and let me write out something really quickly. When we say, if you kind of heard the is of rules where we say, okay, 30% of a number is 8.4, okay, right? So of is multiply. So we are going to change this to 0.3 because we're going to change it from the percent to the number. Of means multiply. Our number is our number. We don't know what that is, right? Is means what? Usually?
Equals.
Equals, perfect. 8.4. So here's where our division actually takes place. We've got the 0.3 times the number. So we're going to go ahead and divide by the 0.3 on both sides of the equal sign, right? What we do to one side, we're going to do to the other. That's how we're going to get our number is equal to the 8.4 divided by 0.3. So what you were doing was exactly right. We just had some decimals that were kind of flying around, right? Because now when you do that, the 0.3 here, what do we do with our decimals?
Divide. And then we move them out.
Yeah, there we go. So if we know we're going to go ahead and move this one place, we're going to move that
This place.
one place. So now what is our new equation or our new kind of thing look like?
3 divided by...
Okay, so show me that and then go ahead and do the division.
So for the sake of time, we know
Okay.
that it's 84 divided by 3,
Okay.
which is 28.
Okay, so we know this
So we
is
know
28.
it's 28.
All right,
So
fine.
the number's 28.
So this number is now 28. Okay, so what is 37.5 of the number? What are you going to do?
Turn this into a decimal.
Okay.
It already is a decimal.
Oh, well, it is a decimal, but it's a percent.
Okay.
So how we write it as an actual decimal? We're just going to do what we did here, right? We're going to move that decimal 2 places. So if we move that decimal 2 places, what is it?
0.375.
2 places. So we're here.
0.375.
Yeah, 0.375. Okay. So we got kind of a big old mess going on here. But what are we going to do? We're going to go ahead, give us that 0.375. And what are we going to do with the 0.375 when we say what is that percent of the number?
Divide it.
Okay, so
into
remember,
28.
we're going to turn this into equation. What? So our question is what? And then is means?
Equals.
Equals. We're going to write that here, which we've already got. Of means? What does of mean? Of means?
Multiplication.
Multiplication, right? The number, which we know. What was our number? What was our number again?
28.
28.
And that's how we can solve that. If we wanted to do it that way, which is a perfectly fine way to do it, I think we might want to
And
show
for
how
the
to do
use
it.
of time, once again, with a calculator,
Yeah.
that comes out to be 10.5.
Okay. And are we going to show it a little later how to do it a different way?
We can, because,
Okay.
yeah, we can
Multiple
do
ways
it
to
a lot
do
of
it.
different
Yeah.
ways, but
Yeah, yeah.
10.5 is the answer on
Okay.
that.
But that's a
you do that.
perfectly good way to do that, and the division was just right.
All right, well, for a great problem so far, you've got yourself a meal courtesy of our friends at Broken Yell Cafe, so congratulations on that. We're going to do some more math, but right now, a visit from the Kern County Museum. All right, we've got Ashleigh Meyers in studio with us once again. And once again, for the kids that have not seen you, what is your role with the museum?
I am the Curator of Collections at the Kern County Museum. The museum is off of Chester, so it's the local museum here in Bakersfield.
All right, so you've brought in some goodies for us before.
Yes.
And you've got another one right now.
I do, yeah.
All right, so Harjas, what do you think it is? Taking a look at it, what do you think this is? Any idea?
Nope.
I'm going to say it's a box and something else, right? I mean, do you have any ideas what?
Why don't I go ahead and open this drawer here?
Okay.
So now do you have any ideas what it might be?
You're welcome to take a look at this as a hint as well. I'm going to go ahead and start assembling it.
How old is this?
This particular item is from the 1930s.
Okay.
It was, I actually have, I'm doing it the wrong way, aren't I? No? There it is.
I was going to say.
I know, I was
you're
doing
going
it
Isn't
wrong
it the thing you used to weigh something?
Yeah, exactly. So that is close enough. I'm going to take that.
Don't they know what the name is?
You don't know what the name is? The scale. This one in particular is specifically an assayer's scale. And an assayer was, it was a mining profession. And that would be where you would mine like precious metals, like gold and similar others. And you'd bring it in and they'd weigh it for you. Go ahead and take out this one other way just as an example. So flip this lever and now we have our scales. So very old-fashioned scale. Typically now if you see a scale, it's a electronic or mechanical one where you put it on and it tells you in digital numbers how much you've got. Before they had the digital scales, you had to have a standard size weight and then pretty much just attempt to equal it out, right?
And what is the standard size weight that they used or you're using right now?
For this particular profession, for mining, it's actually still used to modern day, but it was used more prolifically in medieval times, but still used to this day, is the Troy weight measurement system. Very similar, it uses a lot of the same terms as our modern day use, so it has an ounce and a pound, but to specify that it is part of the this Troy weight measurement it's called a Troy ounce, a Troy pound, and so on.
Okay.
And again, these measurements really aren't used anymore, really outside of weighing precious metals.
So now this, hold on there, sister. This is pretty slick how this is all put in there like that, like those Russian dolls, right?
Yes, yeah.
Because a lot of times I've seen these different weights and the different measurements, but they never stacked inside of each other.
This is probably just mostly used for the compactness of it.
Portability.
Yes, Exactly. Because otherwise, you get ones that look like this that make it a little bit hard.
Right, to carry all around.
Right.
Okay.
So when you're, single person just trying to find your, going around to different areas and finding what you've got. See, that doesn't make much of an effect there. And you can tell, oops, that this one says 1/4. And this one is probably just a standard 1 ounce, 1 troy ounce. So if I find this.
So Harjas, how many of those would you need to make this balance if this was 1?
4.
Right, you need 4 of those, right?
Right, and you can see as it goes up, we've got this one is 1/2. So this one's an 1/8. I read that wrong. So.
Well, it's old. Maybe it's worn a little bit.
Yeah, it's a little worn. So this is 1/2. Doesn't do much to move it. This one, it's the 1.
So it better balance then, right?
Mm-hmm.
So
now
does
it's
that
just
look
gotta.
balanced to you? Get down like this, right? You want to get down and you want to take a closer look at
And
it.
you'll see there's this pointer here, and it'll.
All right, wait till it stops moving.
Pretty balanced.
So Harjas, I've got a question for you. Do you think if you put this on a different part of this dish, right, would it affect this? Or should it affect it? Like instead of putting it both in the center, I leave this in the center, but if I move that to one side, do you think it will have any effect on it?
Maybe because it might be uneven.
Where do you think we should move it? North, south, east, or west? And we'll have Ashleigh do it since she's got the gloves on.
East.
East? All right, so you're going to bring it closer to the center,
All right.
all the way over as far as you can.
Oh, that's as far as we can get without it.
So we'll wait till it starts. And so do you think it's going to make it a little heavier on that side now? Because in reality, should it affect it at all?
No.
No, right. Because you're like, all right, everything that is in that should still weigh the same, regardless of where in it it's placed. How's it look?
They're different now.
They're different?
Little.
A little. How precise is it a little? And remember, they're still moving a little, right?
Maybe like a centimeter or so.
Okay. So I'm glad that you've got that graduated eyeball right there where you can take a look at that and see that. So nicely done. All right. So anything else you'd like to tell us about this, Ashleigh?
I don't know. Do you have any other questions?
I think that's it. I mean, so you did pretty well once you saw that. You kind of knew that it was used to measure something, right? It's a scale, so that you can measure, and then what it was mostly used for, and how old this is. So lots of treasures at the Kern County Museum, correct?
Yes, yeah.
So if somebody wants to find out more, where should they go as far as online and find out more information?
We do have a website. You can look up the website. Right, yeah, there it is.
It's right on screen, right? So kerncountymuseum.org.
And there is actually an estate office, so you would see a couple more scales inside that window when you go up to that office building.
Oh, good. All right.
Yeah.
Well, Ashleigh, once again, thank you for coming in. Certainly is a treat every time you bring something in and have the kids kind of figure out what's going on. What is it, first of all, like that? So nicely done. And speaking of nicely done, we'll see how the food is coming along with Miriam on Culinary Calculations.
So I have some onion powder here. We've already got black pepper and salt. Onion. And yes, it does need onion powder even though we have fresh onion in it. And the reason for that is because those are two different flavors. So when you're cooking, you're trying your best to layer your flavors, right? That fresh onion's gonna have more of a kick to it. And if we cook it further, it'll be sweeter and more caramelized. But the onion powder is made by drying out onions at low heat. So it's gonna give you a true onion flavor, almost like you'd get off of like sour cream and onion chips, minus the sour cream. All right, now we're going in with mustard powder. And yes, this is the same stuff that makes your yellow hot dog mustard. The only difference is there's no vinegar. And then we're going to go in finally with some smoked paprika. Now, sometimes you'll see smoked paprika labeled as hot paprika. It's not spicy, it just means that it has more of a smoky flavor to it. Smell that, that's yummy. All right, just a little bit of that. Give it another stir. You can see that in our pan, we're getting some color on our onions, a little bit of char. I'm gonna turn my heat down a little bit, focus my attention on this brisket. So you can see it's already pretty shredded, and if you like your brisket nice and shredded and pulled like pulled pork, then you can do it this way. Now if you're get a larger chunk, or your brisket's a little less well done than ours, then you can cut it through and dice it and cube it, just like you would do your peppers or onions. This looks pretty good to go. I'm gonna put this all in a pan. Now, I've got some bits left on my cutting board. I'm not gonna use the side of my blade like this to scrape that clean, because that, one, dulls the knife, two, is dangerous if you're going towards your hand. So what we're gonna do is we're gonna flip it and use the backbone of the blade to scrape all these goodies into our hand and into the pan. Now, all this little pasty white stuff is the fat from the brisket, because it cooked for about 6 hours yesterday. So the meat let go of all of its lovely juices, it let go of all of its fat, and now we're reheating it and it's gonna change color. You'll see it go from a light pink to a darker brown red. And it'll still stay a little pink because we make good brisket. Now, last but not least, we have these potatoes that we boiled for soup yesterday and didn't use. Those are gonna go in too. And this is where the rubber meets the road. You're gonna get your food into a location that you like, right? It's all evenly spread out in this pan. And then we're going to turn our heat up a little bit, and we're just gonna let that sit. We want those potatoes to crisp a little. We want the brisket to crisp. And guess what? We don't even need to add any more fat or oil, because the brisket, like I said, has all of that fat kind of stuff in it. So, while that's cooking, let's talk about our herbs and our eggs. Now, corned beef hash is this technically. It's potatoes and corned beef. When you see it in a restaurant, it's often served with eggs. So we have these Happy Hen Egg Company eggs here that we are going to crack just over it whenever it's done. It'll be kind of like a nice skillet breakfast. So I'm gonna grab a beautiful brown egg, 2 white eggs. I think I'm probably gonna need a 4th egg too. Let's go for it. Let's do the blue one. We're gonna do all 4 or 5 eggs. Nice big meal, yeah? These are chives. Chives are different than scallions. Scallions are the back green end of a green onion, technically the stem. Now, the way that they are similar is they're both alliums. Allium is the word for garlic, onions, chives, which is what these are. And we're going to cut these chives nice and fine. Now, you guys see the motion, right? This is kind of our chopping motion. We call it the choo-choo train. Gonna chug all the way to the tips of these chives, and then we're gonna set that aside to top and garnish our meal. Then we have our lovely fresh parsley that I just bought at the farmer's market from H&A Farms again. We're going to do a chiffonade. Now, a chiffonade you can do with any large leaf herb. We're going to kind of layer our herbs in a nice stack, and then we're going to just use our fingers to gather them up, catching any stray ones that fall, and roll, roll, roll. After you've got it nice and tight, we're going to go through again. Here's our claw, and we are going to finally chop these herbs. There we go. Now we have some nice kind of like ribbon slices of the leaf as opposed to like a dice that we have on our chives. It's fun to add texture and color when you cook. And I think now's a good time for me to add in the rest of my tender herbs. So, rest of the parsley goes in.
All right, always nice to see Miriam and those culinary calculations and all of the different goodies that she always comes up with, and all of the leftovers today and what you can kind of do with those. You hungry after looking at that?
Not
Old
really.
man is, I'll tell you
I'm
that
hungry.
right now. Look at that kind of
I'm ready.
All right, you guys back over to the board. So you and Cece, we came up with the 10.5 as the answer when you multiply those, but Cece's going to go over with you a different way to achieve that same answer.
Yeah, so we kind of have a big old mess here. So I'm going to go ahead and we're going to go to a different page. We're going to go, all right, so it was 30%,
30% of 8.4.
8.4.
Of a number is 8.4.
Oh, yeah, okay. The number is 8.4, and we were looking for
37.5% of that.
Okay, what? Okay, so is what? Okay, so anytime we see kind of like a comparison where they say, well, this is this one is what? So anytime you kind of see that kind of comparison, we can do it in what's called a proportion. Have you done proportions before?
I don't think so.
Okay, so we're going to do them kind of, it's basically like fractions. And there's a couple of ways we can do this. So we're going to say, I can leave it as the percent. You want to leave it as a percent, or you want to change it to a decimal?
Decimal.
Okay, fine. So we said 30% can be written as a decimal, right? And we're going to go ahead and we're going to say 30% or 0.3 is, and you're going to put the 8.4 down here. So that's the first bit of information I have. And we're going to say is equal to, now remember, up here we had the percent, down here we had the what is it? We had a number, right? So, okay, we need to do the same thing on this side. So what's the percent written as a decimal, since we did that here, of this? Okay, and then look, we've got this big question mark. Do you usually write things as question marks? Do you ever write them as X's? Have you seen that before?
Usually like variables.
Okay, so go ahead and put your variable down here.
All right, and as you guys put the variable right there, what you guys are going to be able to do is cross multiply and divide while we check out Miriam's final part.
Okay, so go.
Let's check on our potatoes. Oh yeah, you guys can see it's getting all crispy. Let's give that a toss. Woo, yum. All the bits. Nice char, good color. Got some darker spots in our crispy meat, yum. You can see the potatoes are starting to brown and fry. We're almost ready to add our eggs here. I'm gonna add at this point about half the parsley in. You can add anything you like to a hash. There's a million options in a hash. And what's cool about a hash is you can have it any time of day. It doesn't have to be neat and tidy. And it tastes great every time. So again, we're gonna even it out. And now, it smells like we need more salt and pepper, and I'm gonna trust that. Just give it a little bit more. Maybe hit it with some more paprika. And again, smoked and hot paprika are the same thing. If you're getting sweet paprika, that's the stuff that everybody complains has no flavor. Paprika has plenty of flavor, you just gotta get the right one. You know what else I'm gonna do, because I feel like getting a little strange? Some chipotle pepper. Just to like up that smokiness a little bit. I'm gonna turn my heat down just a smidge. And on this like medium-low flame, it's time to crack in our eggs. Now, when you crack eggs, little trick, right? How many people have cracked eggs on the side of something sharp? That's what we're all taught because we think, right, something sharp, it's gonna crack through easier. That's true. But also, if I crack through something sharp, look at all the tiny little bits and pieces of shell that are gonna fall into my food. So, Get rid of that egg. Ooh, very risky, not nice. What we're gonna do instead, we're gonna crack it on a flat surface. You guys can see there's just a little place to enter there. We haven't cracked any of the shell yet. Nice and clean break. Right in the pan. If you get really good at it, you might be able to handle it one-handed. Oh. There we go. And now I'm going to wash my hands and I'll meet you back there. Now, a couple more things. We're going to season once again, because you're going to season every single thing you cook with. The reason for that is we're going back to these layers of flavor. If you season each item separately, then you can guarantee that all together it's going to be seasoned correctly, right? If I season my potatoes, if I season my eggs, I know nothing's going to be bland. Now, if I season my potatoes too much, I might season my eggs a little less to make up for it, but we're pretty good here. Now, one more trick I have for you. These eggs are going to take a second to cook. I could cover it, and I should cover it, but this is a pretty big pan. So I'm going to cheat and use some water. And that's just going to steam in the pan, and the eggs will start to cook a little faster. And don't worry, the pan is hot enough that that's not going to ruin the lovely crispy bits we have. Just going to try and cook these eggs a little faster. You can see already the whites are starting to firm up a little faster. Now, that's one way to do a hash, right? Another way is we get scrambly with it. And I'm feeling a little destructive, so we're gonna go for it. I'm gonna pop these yolks. We're just gonna mix it all together, darn it. And then we're gonna let it sit almost like a little omelet. And I think now's a good time for me to add in the rest of my tender herbs. So, the rest of the parsley goes in. And my chives too. Give it a little toss. And that's it. We used our leftover brisket and boiled potatoes to make a yummy corned beef hash for breakfast, lunch, or dinner.
We'll just have to bring her in studio and do that sometime. All right, Harjas, explain what you've done.
So what we've done is we've cross-canceled. So and once we
Cross-multiplied.
Cross-multiplied. Once we cross-multiply, you get this. Then to find out what x is, you have to divide. You divide 0.3 by 0.3, and when you do one side, you do the other. So you divide by 0.3. Once you get the answer for 3.15 divided by 0.3, you get 10.5. So
Good.
x equals 10.5.
So I can tell you learned something. Did you have fun?
Yes.
Good. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.